Good morning, everyone. This is one more session with respect to Linux system programming. In the chat box. Thank you very much. If you're able to recollect, what is the discussion happened in the last session? In the last session, some time-related issues we are trying to understand. Yes or no? In the last session, some time-related discussion happened. Time is one of the function which will return the time in the form of seconds as a reference point as 1970 January 1st. Because it will return the time in the form of the seconds, if we want to display properly, we taken the help of which function? To display properly, we taken the help of one function called cTime function. And can you tell me, in a stat structure, time related, how many members are there? In a stat structure, time related, how many members are there? Answer is 3 members. st underscore a time, st underscore m time, st underscore c time. Can you tell me when this st underscore c time is going to be changed? Can you tell me when this st underscore c time is going to be changed? If you modify some of the members of inode structure, inode table, then it is going to be changed. A time, when this A time is going to be changed? If you open a file for reading purpose, A time is going to be changed. Such type of discussion happened. After that, we started thinking about one more type of file. What is it? We started thinking about one more type of file that is called a directory file. We are trying to understand how to open a directory file. Directory file is nothing but a file which contains the file names and inode numbers. Again, directory file is nothing but a file which contains the file names and inode numbers. In the last session, we are trying to understand how to open a directory file, how to read the content of directory file, how to display the file names we are trying to understand. And I told you in our material, the ls command implementation is there, ls-li, whatever it is. I told you to go through that. So today's topic will be file handling using system calls. Again, today's discussion will be on this concept. The concept name is file handling using system calls. In a C language, we discussed file handling using library functions. Again, in a C language, we discussed file handling using library functions. Now we are going to discuss the file handling using system calls. Will you agree? Library functions are the functions supported by are the functions supported by, can you tell me the answer? Compiler, correct. And system calls are the functions supported by OS. Can you tell me what are the functions we discussed when we are discussing the C language related to files? What are the functions we discussed in a C language when we are discussing the file-based operations? fopen, fgetc, fputc, fgets, fputs, fscanf. Will you agree? Like this, we discussed it. Now, can you tell me, in a file, if you want to do character by character operation, which set of functions you will choose? In a file, if you want to do the character by character operation, if you want to do character by character operation, which functions you will choose? Can I say fgetc and fputc? In a file, line by line fetching you want to do, then which function you will choose? fgetS, line by line operations, fgetS. Word by word operations, will you agree? fscanf. But today, whatever we are going to discuss, that is little bit different from whatever previously we discussed it. Today, we are going to talk these functions. If time permits, these functions we need to. All of you observe here. Open system call, read system call, write system call, create system call, close system call, dupe to fcntl. Today's our main focus will be on these things. Later we need to discuss about these functions. Again, today our main focus will be on these things. And later we need to discuss CREAT. There is no E here. Note down this function names: open, read, write, create, and close. Open, read, write, create, and close. All the discussion what I'm doing here, it is there in our material which we shared it. You may have some physical copy also. So very simple. Open system call is used to open and possibly to create a file or device and returns a file descriptor. Today we need to talk about a file descriptor. Now can you tell me what is this fopen? Returns. What is this fopen returns? File pointer. File pointer is nothing but a structure pointer. Will you agree? fopen returns a file pointer. File pointer is nothing but a structure pointer. Capital File is a structure. But open system call returns file descriptor. We need to understand what is a file descriptor and all other things. What is the next? Read system call is read from the file descriptor. Write is used to write to a file descriptor. Close is used to close the file descriptor. So open system call is used to open a file descriptor, open a file, and it returns a file descriptor. Open system call is used to open a file and returns a file descriptor. Read system call is used to read the data from the file. Write system call is used to write the data into the file. And close system call is used to close the file. Can anybody tell me? Can anybody tell me what is the first argument and what is the second argument of fopen function? Have you remembered? Have you remembered? What is the first argument and what is the second argument of fopen function? First argument is the path and the second argument is the mode. First argument is the path and the second argument is the mode. Will you agree? First argument is the path, second argument is the mode. Upon success, what fopen returns? Upon success, what fopen returns? Can I say one structure pointer? Normally we'll call as a file pointer. Okay, upon success, it returns one structure pointer. Normally we'll call as a file pointer. I remember this discussion. Different modes R plus W plus A and A plus and all other things. And this is the prototype. First argument is the path, second argument is the mode. But today, whatever we are discussing, man page 2 means, can you tell me man page 2 means? Man page 2 means, will you agree it is a system call? Now observe, how many arguments we need to pass to this open system call? All of you copy this. How many arguments we need to pass to the open system call? 2 or 3? You can pass 2 arguments or you can pass 3 arguments. Again, how many arguments you can pass to the open system call? 2 arguments or 3 arguments, depends upon your requirement. What is the open system call returns? What is the open system call returns? See the prototype and tell me. What is the open system call returns? Can I say it returns an integer, but fopen returns pointer. Fopen returns a structure pointer. So now one thing is, so why I'm comparing this, because it is very easy to understand. Why I'm comparing this discussion with the previous discussion is so that it becomes easy to understand. Now tell me, the first argument of this and the first argument of fopen is the same. The first argument of open system call and the first argument of fopen is the same. First argument of open system call and the first argument of fopen is the same. Second argument here, string. Will you agree? Here it is a string. Second argument here it is a string, but here it is a flag. Here it is a flag. Getting the point? First argument, there it is a string. Here it is a flag. So there are two types of flags are there. One is called mandatory flags and another one is called as a optional flags. Again, note it down. There are two types of flags are there. One is a mandatory flag. Another one is optional flags. Mandatory flags means, can you tell me? Mandatory flags means you must and should use. Will you agree? Mandatory flags means you must and should use. You must and should use. Optional flags means depends upon your option, depends upon your requirement, you need to use it. Will you agree? Mandatory flags will be there, optional flags will be there. Observe. These are the mandatory flags. In these three, depends upon your requirement, you must and should use one of the flag. Again, these are mandatory flags. In these three, depends upon your requirement, you need to must and should use one. Observe. O underscore RD only. Can you tell me when you need to use this flag? When you need to use this flag? Very simple. If you want to open a file for reading purpose, you need to use read only. WR only, writing purpose. RDWR, read and as well as write. Getting the point? O underscore RD only, read only. O underscore WR only, write only. O underscore RDWR, read as well as write. What are these three flags? What are these three flags? Is mandatory flags. In these three, one of the flag you must and should use as a second argument. In these three, one of the flag must and should use as a second argument. If this point is clear, type M in the chat box. I'm talking about a second argument of open system call. Second argument is flags. Flags are categorized into two things. One, it is a mandatory flags, and another one, it is a optional flags. Mandatory flags are three. In these three, you must and should use one flag. O underscore RD only, O underscore WR only, O underscore RDWR. O underscore RD only, O underscore WR only, O underscore RDWR. Next, when you come to the optional flags, there are so many optional flags are there. O underscore create, O or more than 0 optional flags, you can use it. 0 or more than 0 optional flags, you need to use it. No, it will be better, it will be good if I write a program and if I show you. And what are the header files we need to include? Can you tell me what are the header files we need to include? Sys types, sysstat, and fcntl. Sys types, sysstat, fcntl. I think these two header files are already there in our header file, header.h. Now one header file I need to add now in a today's session, that is fcntl.h. Will you agree? fcntl.h. fcntl.h. Now observe today's date 2409_1.c. Hash include. Can you tell me the system call upon failure what it will return? This system call upon failure what it will return? -1, definitely. Upon success, one file descriptor. What is one integer? Fd is equals to open system call data file o_rd only. Now, how many optional flags are used here? Can you tell me how many optional flags are used here? 0. Now observe, if fd is less than 0, the error open system call return, else printf fd is equals to %d/n, fd. Now can you tell me, using the open system call, I'm trying to open a file for what purpose? Observe the line number 6 and tell me, using the open system call, I'm opening the file for what purpose? Can I say for reading purpose? Is there any disturbance coming in my voice? Is there any disturbance is coming in my voice? No. So the student who asked some disturbance, please cross check from your side. BE9S15, please cross check from your side. Background, some construction is going on backside of my apartment, so that may be the sound, but total rooms are closed. Give me 1 minute of time. I'll close the windows and doors properly. Give me 1 minute of time so that I'll close everything properly. Now I hope one window is opened. That may be the reason. One door is opened. This may be the reason. Now I hope, is it clear? Is the voice is clear? Okay. Now observe. Now observe. I'm opening the file. The name of the file is data file for reading purpose. Upon failure, it returns. Upon failure, it returns -1. If it is less than 0, I'm displaying what is the reason for the failure. I'm displaying what is the reason for the failure. Otherwise, I'm printing this file descriptor. Otherwise, I'm printing that file descriptor. Will you agree? I'm printing that file descriptor. Let me compile the code. Let me show you the output. Just a minute. Just now observe. We got FD as a 3 because, will you agree, in the present working directory, the data file is there. In the present working directory, data file is there. I got 3, a reference number as a 3. Suppose if I remove the data file, now if I run the program, will you agree? Open system call is failed here. Will you agree? Open system call is failed here. Open system call is failed here. Now you may get a doubt, sir, why we are getting, you may get a doubt, sir, why I am getting 3? Now I need to tell you background what happening here. Now I need to tell you background what happening here. Whenever a process is created, now we are learning about a processes and all other things. Listen, whenever a process is created, you know, PCB is created. Will you agree? Whenever a process is created, will you agree? PCB is created, process control block. Similarly, whenever a process is created, signal table is created. Similarly, a signal table is created. Similarly, whenever a process is created, one table is created that is called file table. Similarly, whenever a process is created, there is one table is created that is called file table. Getting the point? Whenever a process is created, how a PCB is created, how a signal table is created, in a similar way a file table is created. One more thing I need to tell you, all of you are getting the point what I'm saying, type 2 in the chat box, whatever the discussion is going on. One more thing I need to tell you, whenever a process is created, by default 3 files are automatically opened. Again, whenever a process is created, by default 3 file descriptors are opened on the program's behalf by the shell. Now will you agree? Shell is a parent of our program when we load our program into the RAM for execution. Will you agree? Bash shell is a parent process for our program when we load our program into the RAM for execution. So what the shell will do, it will open these 3 files and it will give it to us. What are the 3 files? std in, std out, std error. std in, std out, std error. again, std in, std out, std error. So these are the three file descriptors. Can anybody tell me how many files a process can open at a time? How many files a process can open at a time? Can I say 1024? So by default, whenever a process is created, how many files are opened automatically? By default, whenever a process is created, how many files are opened automatically? Answer is 3 files are opened automatically. What are those? Those are std in, std out, std error. Now tell me what you will feel that in your program, you will feel that you are opening this is the as a first file. Will you agree? Line number 6, what we will think that we are opening this file as a first file, but actually already, can you tell me what we will feel that we are opening this is the first file, but already 3 files are opened. Already the 3 files are opened. Already the 3 files are gets opened. Getting the point? std in, std out, std error. So can I say, according to us, this is the first file we are opening. According to us, this is the first file we are thinking that opened. This is the 4th file. Every time whenever a process is created, these 3 files are automatically opened. Again, every time when the process is created, these 3 files are automatically opened. All of you are getting the point? File descriptor 0 is refers to file descriptor 0 is refers to file descriptor 0 is refers to std in. File descriptor 1 refers to file descriptor 1 refers to file descriptor 1 refers to std out. File descriptor 2 refers to file descriptor 2 refers to std error. Again, file descriptor 1 refers to file descriptor 1 refers to std in. File descriptor 1 refers to std out. Correct. 0, 1, 2. 0, 1, 2. File descriptor 0 std in. File descriptor 1 std out. File descriptor 2 std error. So that is the reason you are getting this as a 3 now. That is the reason you are getting that as a 3. So here I am opening the file for what purpose? Here I am opening the file for what purpose? Reading purpose. One thing I need to tell you, when you open a file using fopen data file in the read mode, you will get a file pointer. Will you agree? With this file pointer only, you need to do all the operations in f put c, f get c, and whatever the functions you are using on the files, you need to pass this as one argument. Whatever the functions you are using in a file, this is one argument you must and should. Similarly, whatever the file based operations we want to do using the system calls, this is a reference number. That is a reference number. With that only you need to use read system call, write system call, whatever you want. Again, I hope all of you are getting this point. I hope all of you are getting this point. What is the use of this file descriptor? In further process of file operations, in further process of file operation, file operation, this descriptor we need to use. Some of the interviews they will ask you, what is the difference between the file pointer and file descriptor? Again, some of the interviews they will ask you, what is the difference between the file pointer and file descriptor? What is the difference between the file pointer and file descriptor? You need to say file pointer is a structure pointer. You need to say file pointer is a structure pointer. File descriptor is a integer value. File pointer is a structure pointer. File descriptor is an integer value. Getting the point? File pointer will point to one structure. File descriptor is a small positive integer. File descriptor is a small positive integer for future reference file operations. For future reference file operations, this file descriptor is used. This file descriptor is used. Getting the point? Next, one thing I need to ask you, if I open a file, fp is equals to fopen data file in the write mode. Now tell me, if the file is not there, will it create? File is not there, will it create? Yes. File is there, will it truncate? File is there, will it truncate? Yes. But try to understand here, but in this case, fd is equals to open data file o underscore wr only. O underscore wr only. I am opening the file for what purpose? I am opening the file for what purpose? Writing purpose. Let me check it out. Let me show you something here. File is there, but observe, is the content is truncated or not? But observe, is the content is truncated or not? But observe, is the content is truncated or not? Can I say it is not truncated? Will you agree? It is, the content is not truncated. Now one more thing, if you want to truncate, which optional flag I need to use? If you want to truncate, which optional flag I need to use? O underscore trunc. Again, if you want to truncate, you need to use R with O underscore trunc. And also, If the file is not there, this will not create. Very important point. If the file is not there, this will not create the file. If you want to inform to open system call to create a file, you need to use, if you want to open system call to create a file, you need to use one optional flag that is called O underscore CREAT. One optional flag you need to use O underscore CREAT. All of you are getting the point? All of you are getting the point? This information, I think it will be available here. Observe. Observe, all of you see this. Fopen in the write mode is equivalent to WR only, create and truncate, and permissions you need to give. All of you are observing this line. So now these two becomes an equal. If you don't write this, then these two are not equal. Can I say open system call is used to open a file but not to create a file until and unless you use a create flag? Listen the statement very carefully. Open system call is used to open a file, not to create a file until and unless you use create flag. Getting the point? Open system call is used to open a file, not to create a file until and unless you use create flag. If you got this point, type 1 in the chat box. Open system, why is 0666 means? This is the permissions, user, group, others. 6 means 110, 110, 110. User can read, user can write, user cannot execute, others can read, can write, cannot execute. You can give 0600 also. If you give 600, then if you give 600, only user can read and write. Others and group members cannot do any operation on the file. So this mode you need to supply only when you use a create flag. Otherwise, no need to supply this. The student who asked the question, is that clear? So in open system call, when you are using as a create, you need to supply the mode here, permissions there. Mode is nothing but here permissions. Your wish what permissions you want to give to user, your wish what permission you want to give to the group members, your wish what permission you want to give to others. C will not support the function overloading. This is not the C library function. This is a system call. B8F1. This is not a library function. This is a system call. So they implemented like this. So this is some exceptional case. You can, two prototypes will be there. So which function call, which way you are calling, the compiler will accept that. Is it clear? Okay. Now observe. Now can I say open system call is basically is used to open, not to create. Here we are giving the permission to user, group, others. Here we are giving the permission to user, group, others. when we are discussing the ls command, have you observed read, write, execute, read, write, execute, read, write, execute? So that is the permissions. Getting the point? That is the that permissions you need to supply. But in fopen function, we no need to worry about all these things. In fopen function, we no need to worry about all these things. Now observe, fopen w plus mode is equivalent to, all of you observe here, fopen w plus mode is equivalent to open rdwr, create, truncate, and permissions. Now tell me, when you open a file in W plus mode, you can read as well as you can write. When you open a file in a W plus mode, you can do reading as well as writing. And if already file is there, the file is truncated. If file is not there, it will create it. If the file is not there, it will create it. So will you agree? fopen W plus mode, if want to write using the open, so these optional flags, this mandatory flags, and this mode we need to supply. Getting the point? Now next, what is that next? A plus mode. A plus mode. Now can you tell me, in a plus mode, just a minute. In a plus mode, you can do reading and appending. Now if you want to do that, observe, read, write, and append. Now tell me, because of this append, writing operation is done in, because of this append, writing operation is going to be performed at the end. Reading operation is done from, writing operation is performed at the end. Reading operation is done from the beginning. Reading operation is done from the beginning. I hope with this examples, you got little bit confidence about the open system call. Little bit confidence, I hope you got. Yes or no? What is the next? Read system call and write system call. Next discussion is on read system call and write system call. Read for reading the data. Write for writing the data into that file descriptor. Read for reading the data from the file descriptor. Write for writing the data into that file descriptor. Again, read for reading the data from the file descriptor. All of you copy the prototype of this read. All of you copy the prototype of this read. All of you copy the prototype of this read. What is the first argument of this read system call? What is the first argument of this read system call? What is the first argument of this read system call? Can I say file descriptor? Will you agree? File descriptor, the return value of the open system call, the return value of open system call. See, BE9S15, this is same as a normal file, but this is operating system level implementations. BE9S15, try to understand. Whatever we discussed in the C, that is a compiler level implementations. So these are the OS level implementations. So they designed in such a way that whenever we open a file using the system calls, they will give us one reference number. With that reference numbers only, we need to deal with the files. I don't know, you remembered or not, when we are talking about what is the capital FILE and all other things, I told you, I might have told you. fopen function internally communicates with the OS. fopen function internally communicates with the OS. So for communicating with the OS, fopen internally uses the open only. fopen function internally communicates with the OS. So fopen internally calls open system call only. But one thing I need to tell you, whatever the fopen functions we used it will deal only with the regular files. Again, one thing I need to tell you, whatever the fopen in a C language we discussed it will deal with only regular files. But open system call not only deals with a regular file, some other type of files also you can deal. Can you tell me how many types of files our Linux categorizes? Can you tell me how many types of files our Linux categorizes? Can I say 7 types of files? Will you agree? So using the open system call, I can deal with using this file descriptor. I can deal with socket file also. I can deal with pipe file also. So this is a generic concept, not specific to regular files. Is it clear? Device driver files also. You can deal with device driver files also. You can open the serial port. Have you heard about the serial port? In a microcontroller, you might have heard about the serial port. In a Linux, if you want, you can open the serial port, serial driver. You can do the reading and writing operations. Then you will get a file descriptor. So using this open system call, not only I can deal with the regular files, not only I can deal with the regular files, I can deal with not only I can deal with regular files, I can deal with other type of files also. That is a benefit of the system calls. Generic, not a specific. Now, can you tell me, if you want to read a character from the file using a library function, which function you will use? If you want to read a character from the file using a library function, can you tell me which function you will use? fgetc. But if you want to read a character from the file using the system call, which function you will use? If you want to read a character from the file using the system call, which function you will use? Read system call. Function, I'm talking about a function. B8K8. Function, read function. Again, I'll write it. Very important point here. if you want to read a character from the file using a library function, you will use fget c, but using the system call read. If you want to fetch a line from the file using the library function, which function you will use? If you want to fetch a line, fgetS, but here which system call? Read only. If you want to fetch a word, fscanf, here read only. All of you are getting? So the library functions are implemented in such a way that for everything separate function is designed, but system calls are not a specific, generic. So that is the reason implementing the program using the system call, you should be very cautious, you should be very alert compared to this. Little bit complications will be there. The program becomes complicated if you use a system call and if you implement the program, because for everything you need to use read system call only. To fetch a character, to fetch a line, to fetch a word, every purpose you need to use a read system call only. For every purpose you need to use a read system call only. Is that point is clear? And these functions only deals with ASCII text files. But these functions, any type of files, like if it is a socket file, if it is a pipe file, if it is a device driver files, if it is a ASCII text file, if it is a binary file, any type of files we can use these functions, whatever we are discussing now. I hope with this you got a little bit more. Not all, maximum every file we can do, not all 7 types of files. With this point, I hope you got little bit additional points with this discussion. Is it clear? Suppose in a Linux, you want to open a serial port. You want to write a data into the serial port. Suppose in a Linux environment, if you want to open a serial port, if you want to write the data into the serial port, then open system call for opening it, write system call to write the character into the file, into the serial port. Serial driver, we can say. Is it clear? Now let's move to the read system call. Read from the file descriptor means it will read from the file. It will read from the file. First argument is a file descriptor. First argument is the file descriptor. Second argument is the void star buff. Second argument is the address location. Any type of data address, character address, integer address, in character variable address, integer variable address, array address, any address. Third argument is the size. Suppose in a file there is one integer, you want to read an integer, so then what you need to do? Suppose in a file there is one integer, you want to read that integer, then what you need to do? Read fd amp fd and ampersand of num comma 4 bytes. Again, in a file, you want to, from the file you want to read one integer. So what is the first argument in file disk, a first argument in a read system call? What is the first argument in a read system call? File descriptor. What is the second argument? After reading the data from the file, where you want to store the data. Again, the second argument is after reading the data from the file, where you want to store the data. Third argument is how many bytes you want to read the data. Third argument is how many bytes you want to read the data. Now tell me, in a file there is a string. I want to read the string. Can you tell me what we should do? Read system call, file descriptor, S, how many bytes you want to read it. Suppose 5 bytes. Now tell me, in this read system, using this function, I am trying to read how many bytes from the file and where we are putting. I'm trying to read how many bytes from the file and where we are putting. Can I say we are putting into the S? We are putting that 5 bytes from the, we are reading 5 bytes from the file and we are putting into, we are putting that into the S. I'll show you, it will be more clear for you. It will be more clear for you. VI 24 2 dots. This demo program is for what? To read 5 characters from file using system calls. Again, this program is for what? To read 5 characters from the file using, to read 5 characters from the file using system calls. Now observe, hash include header.h void main void main int fd is equals to open system call data file o_rd only. I'm opening the file for reading purpose. Okay, if fd is less than 0, something went wrong. To know what is the wrong happened, p error open, and no need to further proceed it, return. Otherwise declare a character array. Declare a character array. Just for the time being, I'm putting this data into that. Some junk data I'm putting it. Now observe, read, first argument is a fd, second argument, how many bytes you want to read from the file? Read, observe the line number 1 and tell me 5 bytes. From where? First argument is, what is the first argument? Sorry. Second argument is, first argument is a file descriptor. Second argument is S. and third argument is 5 bytes. Error read and printf s is equals to percentile s slash n comma s. Observe, I'm trying to read 5 bytes from the file. What is the name of the file? Data file. What is the name of the file? Data file. I'm trying to store that 5 bytes into this S. Now, will you agree, in this S, already some initial data is there? This data is there. Yes, sir. Give me some time. Let me compile the code. Now let's see what is the data file contains. Okay, some data is there. ./a.out. Now observe, is read system call successfully read 5 bytes or not? D, S, F, A, S. Now what about this? Can I say this is old data? Can I say this is old data? So the meaning is, read system call will never bother about /0. Meaning is, read system call will not put /0 into our array. But can you tell me, when we are talking about f get s, I don't know you remembered or not. Here if I pass 10, can I say it will try to read 9 bytes? Here if you pass 10, it will try to read 9 bytes less than the character. And this fgetS will put /0 at the end. This fgetS will put the /0 at the end. But what the read will do? Will it put /0 at the end? Will it read 1 less than what you mentioned here? Will it read 1 less than what you mentioned here? No. Here you told 5. It will try to read 5 bytes from the file and it will store it into this array, and read will not worry about the /0 at the end. Read will not worry about the /0 at the end. Is this observation is clear? Type C in the chat box. If this observation is clear, type C in the chat box. Okay. So then what is the precaution we need to do? What we need to do before reading the data from the file and storing into the buffer? So what we need to do is B0 S comma size of S. Can you guess what is this B0 function will do? Can you guess what is the B0 function will do? Normally, by the name itself, can you tell me? Normally, with the name itself, can you tell me what is the B0 function will do? Can I say it will put zeros into that S? Will you agree? It will put zeros. It will put zeros into that S. Will you agree? So one additional point I need to tell you, using the system call when you are reading the data from the file and storing into our local variable, make sure that the local data, make sure that in a local array, it should be 0. Now let me compile the code. Let me run the code. Now observe, Is that junk data is printed after this here? Is the junk data is printed after that? No. Why? Why? Because can I say B0 putting a zeros? So this one additional point you need to understand. Whenever you are reading the data from the file and storing into this array, make sure that this array should be cleared first. You can use memset also. You can use memset function also. You can open the man page of memset. You can use it. Otherwise, that memset related discussion is here, I think. All of you are observing B0 function, memset function. All of you are observing the memset function here. After the class, you can go through this memset function. So what is that? Is all of you are getting what is the discussion happening? What is the read system call returns? It returns an integer. It returns an integer. What is that integer holds? It will not return file descriptor. It will return one integer. Returns number of bytes read, 0 on end of file, -1 is on error. All of you read this point. What is the read system call returns is? It returns number of bytes read from the file upon success. If it is returning the 0, what is the meaning? If read system call is returning the 0, what is the meaning? If read system call is returning the 0, what is the meaning? Can I say end of file? File is ended. Upon failure, it will return. Upon failure, it will return -1. Now, can you tell me, if you want to read one integer from the file, how you will use read system call? Read fd address of number 4 bytes. Can you tell me what is the data type of this NUM? If you want to read one integer from the file, what is the data type of that NUM? Integer. All of you observed it is a void pointer, means generic pointer. All of you observed it is a void pointer. It is a generic pointer. If you want to read an integer, integer address. If you want to read a character, character address. If you want to read an array, array address. So upon success, read returns the number of bytes read from the file. 0 upon file is ended. 0 upon file is ended. -1 upon failure. -1 upon failure. Is this point is clear? Type C in the chat box. Let's go to the write system call. Let's go to the write system call. Observe. Write system call. First argument is the int fd. Second argument is the void star buff. Second argument is the void star buff. Third argument is the size. Third argument is the size. Can you tell me, if I want to write an integer into the file using the write system call, write fd ampersand of num, size of num. If I want to write one integer into the file, write fd ampersand of num, size of num. If you want to write a structure into the file, write fd address of s1, size of s1. S1 is a capital ST S1. Getting the point? Capital what you call size of S1. All if you're getting this, how to use a write system call. All if you're getting how to use a write system call with this examples, type 2 in the chat box. All if you're getting how to use a write system call with this example. First example, how to write an integer into the file. Second example, how to write a structure into the file. Different types of data also. Suppose you have an array of 5 integers. Can you tell me, suppose you have an array of 5 integers, how to write? Write fd a size of a. Instead of writing directly 20, you can write size of a. B8 F1, got the point? Instead of directly writing 20, you can write size of a. Now let's see, upon success and upon failure, what it will return. Returns the number of bytes written or -1 on error. Observe all of you. Upon success, it returns how many bytes it written into the file. How many bytes it written into the file, that it will return upon success. Upon failure, it returns -1. Upon failure, it returns -1. Is this read and write system call is clear? If this is clear, I am going to talk a very interesting and very important concept now. Observe 2409_3.c. Observe very tricky discussion. Header.h void main. Now tell me, int fd is equals to open system call data file o_wr only, write only o_trunc and o_creat comma 0664. I given 664. You can give 600. You can give 666. Now can you tell me, as I told you today, open system call is not basically used to create a file until and unless you use. Open system call is not used to create a file until and unless you use create flag. Will you agree? Open system call is basically used to open a file, not to create. Now tell me, I'm opening the data file for write purpose. If the file is already there, I'm truncating it. If file is not there, I'm creating it. While creating, these are the permissions given. While creating, these are the permissions are given. Will you agree? While creating, these are the permissions they given. Okay. If fd is less than 0, what is the meaning? Can I say something went wrong? P error, open system call, no need to further proceed it. Otherwise, printf fd is equals to hello world. Fd is equals to %d/n comma fd. Now where the printf will print? Now can you tell me where the printf will print? Std in, std out, or std error? Now you should not say the term called screen. You need to say little bit proper answer. STD in or STD out or STD error. Answer is STD out. Will you agree? Where the printf will print means, can I say it will print into the STD out file, STD out buffer. Will you agree? It will print. And can you guess what will be the FD holds here? Can you guess what will be that FD holds here? 012 is already reserved for 012 is already reserved for in out error. Can I say FD holds 3? Hello world, FDS 3. That's what the expected things only. Hello world, FDS 3. Now observe, before opening this file, I'm closing. Before opening the file, I am closing the one. One means before opening the file, I am closing the one. One means STD out. Now let's see where the printf will print, because STD out is not there. STD out is not there. Now printf is not printed on the screen because STD in, STD out, STD error, these three files 0, 1, 2. So printf will print the data into STD out, but STD out is not there. I closed it. That is the reason. Now observe very interesting point here. Open the data file. Observe. Printf is printed into the file. Hello world. And all of you are observing, previously we got 3. Now I got 1. Previously we got 3. Now I got 1. Now what is happening here? Try to understand. What is happening in this program? Try to understand. Now first what we are doing, will you agree, by default 3 files are opened? All of you observe, all of you answer quickly. By default 3 files are opened or not? Today's discussion, I told you, whenever your program is loaded, STD in, STD out, STD error. Which file you are closing here? Which file you are closing here? Now can I say file descriptor 1 is free now? File descriptor 3 also free. It is not assigned to anybody. File descriptor 1 and file descriptor 3, 4, 5, 6 up to 1023. Those are free. Now when you open a file, file manager will assign file descriptor 1 or file descriptor 3, which is lowest available file number, file descriptor number. After closing the one, when you open the file, which is the lowest positive available number is there? Can you tell me? Which is the lowest positive available number is there? Can I say 1? So that is the reason this FD holds 1. Now can I say file descriptor 1 is not referring to out. File descriptor 1 is referring to file called data file now. Again, file descriptor 1 is not referring to STD out. File descriptor 1 is referring to data file. Now I need to tell you what the printf will do. It will print the data into the file whose file descriptor is 1. Again, what the printf will do, printf will print the data into the file whose file descriptor is, printf will print the data into the file whose file descriptor is, printf will print the data into the file whose file descriptor is 1. Now can you tell me, before, if you don't close this, file descriptor 1 is referring to, file descriptor 1 is referring to, file descriptor 1 is referring to out. Please try to understand. If you don't close this, file descriptor 1 is referring to out. So printf will print the data into this out. I'm not talking about this FD. I'm talking about file descriptor 1, BE8N2. I'm not talking about open return value now. When you don't close it, file descriptor 1 refers to, if you don't close it, file descriptor 1 refers to out. But if I close it, file descriptor 1 is referring to, if you close 1, file descriptor 1 is referring to data file, because the lowest freely available number is that only at that moment. Lowest freely available number is that only at that moment. Now tell me, printf, it will not worry it is a std out or it is a data file. Printf simply puts the data into the file whose file descriptor is 1. Printf simply puts the data into the file whose file descriptor is 1. Printf simply puts the data into the file whose file descriptor is 1. So this we need to discuss many more in a tomorrow's session. Please go through this concept called input and output redirection. So what we can do, I can use a printf to print the data into the file also. I can use the printf to print the data into the file also. Input and output redirection. This we need to continue in a tomorrow session. And one more notice, I hope already Manu sir and other faculties might have announced it. That is regarding your reassessment. Those were not recommended. Is it? Regarding your reassessment. Regarding those who are not recommended, regarding the reassessment. In this, I hope for reassessment for BE8 and BE9 batches is there, right? So without forgot, those who are not recommended in the assessment, try to fill this form. Is it clear? Assessments will start from Monday. Monday or Tuesday, we will announce it. Next week, definitely we'll conduct the assessment, from which I'll tell you. Is that is clear? Without fail, try to fill this assessments. Why? Because for BE9 also, maybe in the next week, the placements will start. Definitely it will start. So please try to utilize this opportunity and try to fill this form. Those are non-recommended candidates. It's clear? Clear to everyone? Type C in the chat box so that I'll wind up the today's session. And try to pass this message to your friends also, those who are not recommended. Okay, thank you very much. I'm going to wind up the today's session.